So what's going on here is we already know the sum of n terms is 342, but we don't know how many terms that was. So we can't really plug in this number here. That's going to tell us the first term. So 5 minus 4 is 1. That's the first term. Then maybe I could plug in 2 in for x, so I get 10 minus 4 is 6. That's the second term. The third term, I plug in 3, I get 15 minus 4 is 11. You can see the pattern here, plus 5, 16, 21, 26, and so on. But the problem is I don't know, I'm adding all these numbers up and they're going to equal 342 at some point, and I don't know how many there are. So this kind of method isn't really going to be very good. Instead, what I want to do is use one of these formulas we came up with, u1 plus un. Okay, this one probably not going to work because we don't know what n is, and so we don't know this n, we don't know this n. But we do know this Sn is equal to 342. But instead, we do know the common difference is 5. This is d. So if I plug into the other formula where I do 2 times u1 plus d times n minus 1, set that equal to 342, I might be able to solve this equation. So I know d is actually equal to 5 because of the 5x. Okay, so now if I expand and I do 2u1 plus 5n minus 5, all times n minus 2 equals 342. The problem here also is I have too many variables. I have n and I have u1. But I just calculated u1 was equal to 1 by plugging in 1 into the formula. 5 times 1 is 5 minus 4 equals 1. So if I replace 2u1, if I replace this with a 1, then I just have 2 minus 5 is negative 3. So really I have 5n minus 3 over here. And now I'm in a position to solve this. If I multiply this side by 2, 342 times 2, then I can get rid of this 2 on the bottom here. Okay, but now I need to distribute the n. So I get 684 equals, I'm going to come all the way up here. If I distribute the n times 5n is 5n squared. N times negative 3 is negative 3n. And you notice I've got a quadratic equation. So if I move this over here, so I get negative 684. Now I need to solve this equation for n. And in order to do that, we learned a long time ago that I have this poly root finder here. So option 9, polynomial root finder. If I plug in my 5x squared, and then I want minus 3, that's already like that, so minus 3, and then minus 684. Then I can have the calculator tell me these possible values. And I know here that n is going to be 12 because n cannot be a fraction. So this first option doesn't make any sense. That means that n equals 12.